the vertices of a triangle are 6, 6, 6, 6, 0, 6 and 6, 0, 6, 0. Then the distance between circumcenter and centroid, required the distance between circumcenter and centroid of the triangle formed by given points. Now x axis, y axis, one point 6, 0, it lies on the x axis point, 0, 6, it lies on y axis point, 6, 6. Now the given 3 points form a right angle triangle. Now the midpoint of hypotenuse, is circumcenter. Now consider circumcenter C. C is the circumcenter. Now midpoint of 6, 0 and 0, 6 is 3, 3. 3, 3 is midpoint of hypotenuse or circumcenter of the triangle. Now centroid of the triangle G equals to x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Now that equals to 6 plus 0 plus 6 by 3, or that equals to 12 by 3, 6 plus 6 plus 0 by 3, 12 by 3. Now centroid of the triangle equals to 4, 4. Centroid G equals to 4, 4 and circumcenter of the triangle is midpoint of hypotenuse. Now that equals to 3, 3. Midpoint of hypotenuse 3, 3. Now required the distance between circumcenter and centroid. CG equals to square root of 4 minus 3 whole square plus 4 minus 3 whole square, or that equals to root 2. Now third option is correct. Next problem. The vertices of a triangle are 0, 0, root 3, 3, minus root 3, 3, minus root 3, 3. Then the incenter of the triangle, required incenter of the triangle. Now if suppose given points consider ABC, then length of the side AB equals to square root of x2 minus x1 whole square 3 plus 9, or that equals to root 12. Length of the side AB equals to distance between 0, 0 and root 3, 3, or that equals to root 12. Next BC equals to the distance between B and C, or that equals to square root of root 3 minus of minus plus root 3 whole square plus 3 minus 3 whole square, or that equals to square root of root 3 plus root 3 2 root 3 whole square, or that equals to 12, 3 minus 3 0 whole square 0. Now then length of the side BC also root 12. Next length of the side CA equals to distance between 0, 0 and minus root 3, 3, or that equals to square root of 3 plus 9, or that equals to root 12. Now length of the side AB equals to root 12, length of the side BC equals to root 12, length of the side CA equals to also root 12. The lengths of three sides of the triangle are equal. Then the triangle formed by given three vertices or given 3 points is an equilateral triangle. Now for equilateral triangle, circumcenter, orthocenter, incenter, centroid all are same. Now centroid of the equilateral triangle equals to its incenter. Now incenter equals x1 plus x2 plus x3 by 3, 0, 0 plus 3 plus 3 by 3. Or that equals to 0, 2. The incenter of the triangle is 0, 2. First option. Now next problem. the points 1 comma 3 5 comma 1 1 comma 3 5 comma 1 are two opposite vertices of a rectangle. If other two vertices lies on the line y equals to 2x plus 3, y equals to 2x plus c, 2x plus c, then the value of c, the value of c. Now rectangle, the given 2 points 1 comma 3 5 comma 1 are two opposite vertices of a rectangle. Opposite vertices nothing but extremities of one diagonal, extremities of one diagonal, extremities of one diagonal. 1 comma 3 and 5 comma 1 are extremities of one diagonal of the rectangle, and other two vertices lies on the straight line y equals to 2x plus c, y equals to 2x plus c. Now require the value of c, require the value of c. In rectangle, diagonals bisect each other, or midpoint of one diagonal equals to midpoint of other diagonal. Now midpoint of diagonal or midpoint of 1 comma 3 and 5 comma 1 equals to 1 plus 5 by 2 comma 3 plus 1 by 2, or that equals to 3 comma 2. Now 3 comma 2 is midpoint of one diagonal, then it lies on the second diagonal, it lies on the second diagonal. Y equals to 2x plus c, y equals to 2x plus c. Now substitute the point 3 comma 2 in the equation y equals to 2x plus c, y equals to 2x plus c. Now we get 2 equals to 2 into 3 plus c, or that equals to 2 equals to 6 plus 6 plus c, for implies c equals to minus 4. The value of c equals to minus 4. Second option, second answer. Next problem. The length of the diagonal of a square is a plus b. The length of the diagonal of a square is a plus b. Then its perimeter is, its perimeter, its perimeter. If suppose consider ABCD is a square, ABCD is a square, then given length of one diagonal in square, the diagonals are equal. Length of the diagonal AC equals to same as length of the diagonal BD. Length of the diagonal AC equals to same as length of the diagonal BD. Now given length of one diagonal, consider AC equals to A plus B, AC equals to A plus B. Now length of the side consider S, perimeter nothing but S plus S plus S plus S. Now perimeter of the square equals to 4S. Require the value of 4S in terms of A and B. But the relation between length of the side and length of the diagonal equals to length of the side S equals to length of the diagonal by root 2, AC by root 2. But length of the diagonal AC equals to A plus B. Now that equals to A plus B by root 2. AC equals to A plus B by root 2. But required perimeter of the square ABCD, perimeter of the square ABCD, that equals to 4S. Now that equals to 4 into, but the value of S is A plus B by root 2, or that equals to 2 root 2 into A plus B, 2 root 2 into A plus B. Answer is second option. Next problem. The ratio in which y-axis divides the line segment joining the points 3, 6, 12, minus 3, 12, minus 3. if suppose x axis, y axis, there are 2 points. Consider A x1 y1, another point B x2 y2. Now AB is a line segment. Y axis and AB intersect at the point P. Consider. Now if suppose the point P divides AB in the ratio m is to n, then the coordinates of the point P, now P divides AB in the ratio m is to n, the coordinates of the point P equals to mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. These are the coordinates of the point P. But the point P lies on the y-axis. On y-axis, always x coordinate equals to 0. On y-axis point, x coordinate always 0. Then mx2 plus nx1 by m plus n equals to 0. mx2 plus nx1 by m plus n equals to 0. By cross multiplication, we get mx2 plus nx1 equals to 0, for implies mx2 equals to minus of nx1. mx2 equals to minus of nx1. m by n equals to minus x1 by x2. Therefore, m is to n equals to minus x1 is to x2. Means y-axis divides the line segment AB. Y-axis divides the line segment joining the points x1 y1 and x2 y2 in the ratio minus x1 is to x2. Minus x1 is to x2. Similarly, x-axis divides the line segment joining the points x1 y1 and x2 y2 in the ratio minus y1 is to y2. Now here minus x1 is to x2, or that equals to minus 3 is to 12, or that equals to minus 1 is to 4, or in the ratio without minus sign 1 is to 4 externally. In the ratio 1 is to 4 externally. Now option is third option. Next problem. The triangle with vertices A comma B, A comma A, B comma A, A comma B, A comma A, B comma A. Options: equilateral triangle, isosceles triangle, right angled isosceles, right angled triangle. Now A comma B, A comma A, B comma A. Take x axis, y axis. First point A comma B on x axis at a distance A. On y axis B. A comma B. First point A comma B. Next point A comma A on x axis A, y axis also A. A comma A. Next B comma A. On x axis consider B, y axis A, B comma A. Now in first 2 points x coordinates are equal. In first 2 points x coordinates are equal. In A comma A and A comma B, x coordinates equal. Therefore, the line segment joining 2 points parallel to y axis. In next second point and third point, y coordinates are equal. In second and third points, y coordinates are equal. Now the line segment joining 2 points parallel to x axis. One side of the triangle parallel to y axis and second side parallel to x axis, then compulsory the triangle formed by 2 points, the triangle formed by the 3 points is a right angle triangle. Now it may be right angled isosceles also. Now the distance between a comma b and a comma a, the distance between or length of the side equals to square root of a minus a whole square plus b minus a whole square, or that equals to b minus a. Similarly, the distance between a comma a and b comma a, or that equals to square root of b minus a whole square plus a minus a whole square, or that equals to mod of b minus a. Now the sides of the two sides also equal, two sides equal and one angle is 90 degrees, then the triangle formed by the given 3 points is a right angled isosceles. Then option is fourth option, right angled isosceles. Next problem. The 3 points 2 comma minus 4, 4 comma minus 2, 7 comma 1, 7 comma 1 options form an equilateral triangle, form isosceles triangle, lie on a line, form a right angle triangle. If suppose consider the given 3 points A, B, C, the given 3 points A, B, C. First the distance between A and B, the distance between 2 comma minus 4 and 4 comma minus 2, AB equals to square root of 4 minus 2 whole square plus minus 2 minus of minus plus 4 whole square, or that equals to we get square root of 4 plus 4, or that equals to root 8 or 2 root 2. The length of the side AB or distance between A and B equals to 2 root 2. Distance between the 2 points AB equals to 2 root 2. Next, distance between B and C, BC equals to square root of 7 minus 4 whole square plus 1 minus of minus plus 2 whole square, or that equals to root 9 plus root 9 or root 18, that equals to 3 root 2. BC equals to 3 root 2. Next, the distance between C and A, CA equals to square root of 7 minus 2 whole square plus 1 minus of minus plus 4 whole square, or that equals to square root of 25 plus 25 equals to root 50, that equals to 5 root 2, 5 root 2. Then CA equals to 5 root 2, or that equals to 2 root 2 plus 3 root 2, AB plus BC, AB plus BC. Now CA equals to AB plus BC, then the 3 points are collinear or lie on a straight line. Third option is correct. Next problem. The triangle with vertices 4 comma 0, minus 1 comma minus 1, 3 comma 5, 3 comma 5 is options an isosceles right angle triangle, second option isosceles but not right angled, third option a right angled but not isosceles, fourth neither right angled nor isosceles. Consider the given 3 points A, B, C, given 3 points A, B, C. Now AB equals to the distance between A and B, that equals to square root of 4 minus of minus plus 1 whole square plus 0 minus of minus plus 1 whole square, or that equals to root of 25 plus 1, that equals to root 26. Now the distance between A and B, the distance between A and B equals to root 26. Next, distance between BC, BC equals to square root of 3 plus 1 whole square plus 5 plus 1 whole square, or that equals to root of 16 plus 36, or that equals to root 52. root 52. Next, distance between A and C, CA equals to square root of 3 minus 4 whole square plus 5 minus 0 whole square, or that equals to square root of 1 plus 25 equals to root 26. Now, here AB equals to CA. The two sides equal, then it compulsory isosceles. Also, BC square equals to AB square plus CA square. AB square plus CA square. Now, right angled property is also satisfied, then the given points form a right angled isosceles. Then first option is correct, right angled isosceles. Next problem. The area of the triangle formed by x1 y1, x2 y2, 3x2 minus 2x1, 3y2 minus 2y1. Required area of the triangle formed by the points x1 y1, x2 y2, 3x2 minus 2x1, 3y2 minus 2y1. Now, the third point divide the line segment joining x1 y1 and x2 y2 in the ratio 3:2 externally. Now, if suppose AB is a line segment, A x1 y1, B x2 y2. Now, a point C divides AB in the ratio m:n externally. Then the coordinates of the point C is mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n. mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n. Now, here consider m equals to 3, n equals to 2. Now, substitute these values, we get 3x2 minus 2x1 by 3 minus 2, 3y2 minus 2y1 by 3 minus 2. Now, that equals to 3x2 minus 2x1, 3y2 minus 2y1. Now, the third point divides the line segment joining the points x1 y1, x2 y2 in the ratio 3:2 externally. Now, the 3 points are collinear. Then area of the triangle formed by 3 points is 0. Now, first option is the answer. The points A, 0, 0, B, 1, 1 are collinear. Required the condition. A, 0, 0, B, 1, 1 are collinear. Required the condition. X axis, y axis. First point A, 0. Second point 0, B. First point lie on the x axis point, second point lie on the y axis point. Now, the straight line passing through A, 0 and 0, B. Now, passing through A, 0 means x-intercept of the straight line is A units. Similarly, the line passing through 0, B, then its y-intercept to B units. Then equation of the straight line whose x-intercept A and y-intercept to B is x by A plus y by B equals to 1. The equation of the straight line whose x-intercept A and y-intercept to B is x by a plus y by b equals 1. But third point 1 comma 1 is also lies on the straight line, because given a comma 0, 0 comma b and 1 comma 1 are collinear. Then the third point 1 comma 1 also lies on the straight line. Now substitute the point 1 comma 1 in the equation of the line x by a plus y by b equals to 1. Then 1 by a plus 1 by b equals to 1. Now the required condition is 1 by a plus 1 by b equals to 1. Then first option is the correct. Next problem. The orthocenter of the triangle formed with vertices L comma M, L comma P, Q comma M. Required the orthocenter of the triangle formed by the points L comma M, L comma P and Q comma M. Now take x axis and y axis. First point L comma M, L comma M. On x axis take at a distance L units, y axis M units. The first point L comma M. Next L comma P. On x axis at a distance L, y axis P. Second point L comma P. Now in first point and second point, x coordinates are equal, then the line segment joining 2 points parallel to y axis, the line segment joining 2 points L comma M, L comma P is parallel to y axis, Next point Q comma M. On x axis at a distance q units and M, Q comma M. Now in 2 points, y coordinates are equal. The line segment joining 2 points parallel to x axis. Now one side of the triangle parallel to y axis, other side parallel to x axis, then angle between these two sides is 90 degrees. Then the triangle formed by the given 3 points L comma M, L comma P and Q comma M is a right angle triangle. The triangle formed by given 3 points form a right angle triangle. Then orthocenter of the right angle triangle is its right angled vertex. Therefore the orthocenter of the triangle formed by given 3 points is L comma M. Orthocenter of the triangle formed by given 3 points is L comma M. Answer is fourth option is correct. Next problem. The distance between orthocenter and circumcenter of the triangle with vertices 0, 0, 0, 4, 0, 6, 0, 6, 4, 0, 0, 6. Now required the distance between orthocenter and circumcenter of the triangle formed by the points 0, 0, 4, 0 and 0, 6. X axis, y axis. First point 0, 0, origin. Second point 4, 0. Second point lie on the x axis. 4, 0 lies on the x axis. 0, 6 lie on the y axis. Now the given 3 points form a right angle triangle. Therefore orthocenter, it is nothing but right angled vertex or 0, 0. Orthocenter is 0, 0. Now next the given points form a right angle triangle. A circle passes through three vertices of a right angle triangle, then the diameter of the circle is hypotenuse of the right angle triangle. The diameter of the circle is hypotenuse. Now midpoint of the diameter is center of the circle. Now midpoint of 4, 0, 0, 6 is circumcenter. Always circumcenter of the right angle triangle is midpoint of its hypotenuse. Now midpoint of 4, 0, 0, 6 is 2, 3. 2, 3. Now consider circumcenter C, 2, 3. Now circumcenter of the triangle is 2, 3. Now require the distance between orthocenter and circumcenter. Distance between these 2 points. Now that equals to square root of 2 minus 0 whole square plus 3 minus 0 whole square, or that equals to square root of 4 plus 9 or root 13. Now answer root 13. Option is third option. Next problem. Statement 1. The area of the triangle formed by the points 0, 0, x1, y1 and x2, y2 is half into mod of x1, y2 minus x2, y1. Second statement. The orthocenter of a right angle triangle is its vertex at right angle. Is the vertex at right angle. Now the points 0, 0, x1, y1 and x2, y2 are vertices of a triangle. Now area of the triangle is half into x1, y2 minus x2, y1. Now statement 1 is correct. First statement correct. Next second statement, orthocenter of the right angle triangle is right angled vertex, that is also correct. Now both 1 and 2 are correct statements. Now third option is correct. Next problem. The point B is symmetric to A4, minus 1. A4, minus 1 with respect to the bisector of first quadrant, length of AB. Now x axis, y axis. The point A4, minus 1 on x axis 4, y axis minus 1. Now the point A4, minus 1 is symmetric about bisector of first quadrant. Now divide the first quadrant into 2 equal halves. Now it is bisector of first quadrant. Always bisector of first quadrant is y equals to x. Now B is symmetric about A with respect to the bisector of first quadrant. Then B nothing but image of A with respect to the bisector of or the line y equals to x. Then the coordinates of the point B equals to, or the image of 4, minus 1 with respect to the line y equals to x. The image of any point x1, y1 with respect to the line x equals to y is y1, x1. Now the image of x1, y1 with respect to the line x equals to y is y1, x1, means x and y coordinates are interchanged. Then the image of A4, minus 1 with respect to the line y equals to x is minus 1, 4. Now then require the distance between A and B, the distance between AB. Now AB equals to, the distance between A and B equals to square root of 4 minus of minus plus 1 whole square plus minus 1 minus 4 whole square, or that equals to root of 25 plus 25 or root 50, that equals to 5 root 2. Now the distance between A and B equals to 5 root 2, first option. Next problem. the abscess of 2 points A and B are roots of the equation x square plus 2ax minus b square equals to 0, and their ordinates are roots of the equation y square plus 2py minus q square equals to 0. Then distance between AB in terms of A, B, P, Q, A, B, P and Q. Now if suppose consider A x1 y1, B x2 y2 are 2 points. A x1 y1, B x2 y2 are 2 points. Here the abscess of the points A and B, abscess are nothing but x coordinates of the points. Now x1 and x2 are roots of the first equation x square plus 2ax minus b square equals to 0, x square plus 2ax minus b square equals to 0. Similarly, the ordinates of the points A and B are y1 and y2, y1 and y2 are ordinates of the points. Now y1 and y2 are roots of the equation y square minus 2py minus q square equals to 0. y1 and y2 are roots of the second equation. Now require the distance between A and B. Require the distance between A and B. Now the quadratic equation whose roots are x1 and x2 is x minus x1 into x minus x2 equals to 0. The quadratic equation whose roots are x1 and x2 is x minus x1 into x minus x2 equals to 0. But actually x1 and x2 are roots of the first equation x square plus 2ax minus b square equals to 0. Then x minus x1 into x minus x2 equals to x square plus 2ax minus b square equals to 0. Now x minus x1 into x minus x2 equals to x square plus 2ax minus b square, because x1 and x2 are roots of the first equation. Similarly, y1 and y2 are roots of the equation y square plus 2py minus q square equals to 0. Then the quadratic equation whose roots are y1 and y2 is y minus y1 into y minus y2 equals to 0, or that equals to y square plus 2py minus q square, y square plus 2py minus q square. Now A x1 y1, B x2 y2, consider they are extremities of diameter of one circle. A x1 y1, B x2 y2 are extremities of diameter of a circle. Now the equation of the circle A x1 y1 and B x2 y2 are extremities of diameter is x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. The equation of the circle whose extremities of diameter A x1 y1 and B x2 y2 is x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. Means the given two equations adding, we get equation of the circle AB as diameter. Now the equation of the circle AB is diameter is x square plus y square plus 2ax plus 2py minus b square minus q square equals to 0. The equation of the circle AB is diameter is just by adding two equations we get. By adding two equations we get. Now radius of the circle equals to square root of g square plus f square minus c, or that equals to square root of a square plus p square minus of minus plus b square plus q square. Now it is radius of the circle, but the distance between A and B equals to length of the diameter. Now AB equals to 2 times 2 radius, 2 times 2 radius, or that equals to 2 into square root of a square plus p square plus b square plus q square, or that equals to 2 into square root of a square plus b square plus p square plus q square. Now second answer. Next problem. The points x1 plus t into x2 minus x1, comma y1 plus t into y2 minus y1 divide the join of x1 y1 x2 y2 x1 y1 x2 y2 internally, then now the point x1 plus t into x2 minus x1, comma y1 plus t into y2 minus y1 divide the line segment joining the points x1 y1 and x2 y2 internally. Now required the limits of t. If suppose AB is a line segment, consider A x1 y1, B x2 y2 are 2 points. A x1 y1 and B x2 y2 are 2 points. If suppose there is a point P, consider P x comma y. Now the point P divides AB internally in the ratio minus of x1 minus x is to x2 minus x. The point P divides AB in the ratio minus of x1 minus x is to x2 minus x. Now take x equals to x plus x1 plus t into x2 minus x1. Now substitute in the formula, we get minus of x1 minus x equals to x1 plus t into x2 minus x1 is to x2 minus of x, x1 plus t into x2 minus x1. Now x1 minus x1 cancel, that equals to minus t into x2 minus x1, here minus into minus plus, is to x2 minus x1 minus t into x2 minus x1. Now t into x2 minus x1 is to x2 minus x1 take common 1 minus t. Now x2 minus x1 get cancel. Now t is to 1 minus t. But given the point divides internally means the ratio is positive. Now the ratio is positive. T by 1 minus t is greater than 0. Now numerator and denominator both must be positive, otherwise both are negative. Now if suppose consider t greater than 0, then 1 minus t also greater than 0. 1 minus t greater than 0 or t minus 1 less than 0. For implies t less than 1. Now 0 less than t less than 1. Now the required option is second